and welcome to another video by Programming Knowledge. My name is Ronak Vyas and this video is a collaboration with Programming Knowledge. In this video, we'll talk more about Elasticsearch and how search works in Elasticsearch, how you can figure out the basics, and we'll also talk about how we can use multiple queries in Elasticsearch to search for data efficiently. So in the previous videos, we have talked about how to download Elasticsearch, how to get it up and running. We talked about how to set up Kibana as well, and how we can use Kibana to actually look at the data in Elasticsearch. We also talked about this technique where we can actually run queries on Kibana for Elasticsearch. So we'll talk about that again. And we also index some data into Elasticsearch so that we can see that it's working properly. So, in the previous video, I talked about how the best way to learn Elasticsearch is to go through documentation. So, I'll continue with the documentation as well. And we'll look at the examples given in the documentation and start learning from there again. So, this is where we had stopped in the previous video. We talked about how to index some documents. There was also a video where we talked about how the APIs work. So Elasticsearch works on the REST API. We talked about different kind of APIs which Elasticsearch provides, and that information was enough to actually get started with actually searching and actually working with the main purpose of Elasticsearch and why it is preferred over other NoSQL databases. So to start learning about how search works, we need to index some data, not very less data, but some data in bulk. So we'll start with that. And Elasticsearch documentation helps you here as well. So we have this data here called as accounts.json. So let's just see that for now. So this is a lot of data which we can actually use to search for. So we'll be using this data as our example data and talk about how we can actually search for data efficiently inside the JSON files. So when we have a lot of documents to index, you can submit them in batches using the bulk API. So we'll be using the bulk API right now by Elasticsearch. And this actually makes the operation significantly faster when you are comparing that to individual uh, files that have been uploaded to Elasticsearch. So if you have 100 files, you can use the bulk API to actually divide the 100 files into batches and send them, rather than iteratively uploading every single file for 100 iterations. So the way you divide your batches of 100 depends on the document size and the complexity. So as you can see here, it also depends on the indexing, the search load, and the resources available to your cluster. So it also depends on the kind of memory you have in your computer. So according to the documentation, a good place to start is with batches of 1000 to 5000 and a total payload between 5 MB to 15 MB. You can see the payload information in the Elasticsearch details. So we'll talk about that later. And also they want you to experiment so that you can find the sweet spot for yourself. So yeah, let's get started. Let's start by uploading some documents using the bulk API. So we'll be following these guidelines by Elasticsearch. So I have downloaded the accounts.json file from here. So you can just copy all of this and paste them to a file which is named as accounts.json. And this is how it looks. So it has some bank details, your account number, your balance, first name, last name, age, gender, the address, your employer, email, and so on. So these are the two curl commands that we can use to actually upload the data in Elasticsearch. So as you can see, first is an expost or a post API where you post the accounts.json file to an index called as bank. So it creates an index called as bank and it uses the bulk API here underscore bulk and then refreshes the server. And then after that, we use this command cat indices where we can actually display all the indexes which we have. So we have since we have created a new index called as bank with this command, we then run this command to see if it has actually been done uploaded or not, and hopefully we should see this line here. So don't worry about the health being yellow or green. Anything other than red is completely fine. So if you have a health as yellow or green, that's completely fine. I think the server I am currently using for Elasticsearch 7.6. The health is yellow. I think we saw that in the previous discussion, the previous video. So let's get started. Again, go to your Elastic. Make sure that you have Elasticsearch downloaded. Go inside the bind.B folder and get it running. So just make sure that the processes it runs behind the scenes. All of these, just make sure that you give a glance at it so that you don't get any errors right now. So we have no plugins loaded as of now. We'll be getting to this later. Let's see if the server I have runs smoothly. So it has been started. It has been published the address localhost port 9300, and the cluster health has been changed from red to yellow. So I think we're good to go. Now we'll be using these commands, curl commands, to actually index our bulk data into Elasticsearch. So let's make a new, open up a new terminal, and as you can see, the JSON file which I have is on the desktop. So let's go to desktop, and then let's copy the command, the first command for now, and press enter. And as you can see here, it was just running it on the left, and as you can see, all of these JSON files have been uploaded. Now we can see that they have been uploaded, and you can see the result has been created, but we don't know how many failed and how many passed the uploading process. So for that we use this. So when we use this command, as you can see here for bank, the second one, the health is yellow, open, the index has been created as bank, it has its own unique ID, and the documents that were uploaded were 1000, and I think that is what the documentation also has. So yeah, now we're good to go. We have our data into Elasticsearch successfully. The second thing now is to actually run Kibana. So I forgot that initially, so let's do it right now. Go to Kibana's folder, make sure it's installed, go to pin, and the same way you run Kibana is how you run Elasticsearch. Let's wait for it to load. So currently I was able to run the command using the command line because I have curl installed on my computer. But if you don't, then we had talked about a different way to actually use these commands. It was through Kibana. So you need to have curl installed in a computer to use it from Kibana as well. But it's much easier to do it with Kibana because you can see the outputs clearly. So let's see how that works now. So yeah, I think the server is ready. And let me just look for the port where we have it. So the server is running at localhost 5601. Let's copy that and paste it here. Oh wow, not that, just this. Yep, I know, I'm sorry, I didn't want to search this, and I think we're good to go. Yeah, so now we have opened Kibana, and let's see how we can run our commands for Elasticsearch via Kibana. So go to DevTools, and as you can see, you have this really nice console here where you can actually give some commands and get the outputs directly. So let's try. What did we want first? So we wanted cat indices this. So let's copy that and paste it here. And as you can see, you get the output directly here. And as you can see, the command also changed. So we had a curl command, and it directly got converted to the API. So we have the get API, and we have to cat displays the indices. So that's how we can actually use the console by Kibana to actually see our output directly. So yeah, now we have successfully indexed some data, and now let's start searching. So after this, when you click on the next heading, that is start searching, we can actually see how they want us to search. So what we need to remember before we get into this is that Elasticsearch is a NoSQL database. So everything is in a JSON format. So you have a key value pair, and even when searching for it, you use JSON format with the REST APIs to actually perform the search. And this actually makes it really intuitive to use because you can just form these JSON files and read them as English. So we'll just try it right now. So without any context, without knowing anything about what this is doing, we can actually read and understand what's happening here. So without learning about what the search API is, you want to get something from the bank index. You have a query, okay. So we don't know what query is right now, and you have a query which says match all, and there's nothing inside. So it basically says match everything is what I'm actually understanding from it. And next you sort the account number in an ascending order. So as you can see, it's very simple to read. So the example states that it retrieves all documents in bank index sorted by the account number. Simple as that, and you get the output directly. So it's really easy to write these queries when you compare it to SQL, because you have to actually put your brain and actually sit for some time to actually generate the SQL queries. But here you can actually just write it the way think about it in your mind. So once you have ingested some data into the index, you can search it by sending requests. So you're sending a REST API request to this underscore search endpoint. Now this is called as Elasticsearch Query DSL. What we're going to do here. So these are the basics for that. So let's start with this. So let's copy this and see if this works for us. Sorry. Yeah, so it took 32 milliseconds. We have a lot of things going on here, so let's actually see what all of them mean. So we have the same output. This is what all of it means. So the took says how long it took Elasticsearch to run the query in milliseconds. So it took us 32 milliseconds to do it. Then the next is timed out, with the request of search timed out or not. So this might happen sometimes where Elasticsearch is looking for something which doesn't have, so it times out, the request times out. Just how a simple REST API works. And then you have shards. So we talked about shards in the first introduction to Elasticsearch video, where we talked about how Elasticsearch works behind the scenes. So it divides the document into shards, and then each shard had its own number of documents, and then it loops through all the shards to see if it has found a document or not. So the shards key here shows how many shards were searched and a breakdown of how many shards succeeded, failed, or was skipped. Max score is something which is really important, and we're going to talk about this intensively in the next few set of videos. It is a score of how of the most relevant document found. So the score is null here because we didn't match anything. So when we actually use the query capability, then that is when we have a score, where you give a score to each and every result you get. So higher the score, more the relevant document is for the query. Less the score, the less relevant it is. Next, hits.total.value. So how many matching documents were found. Hits.sort, it sorts position. Hits.score, again the relevant score. Not applicable when using match all, so we need to know that. Now, the next thing which we need to know about the search function, the search API, is that each search request is self-contained. So there is no information that is being maintained across these requests. So each request is an individual request, and there will not be any sort of information that connects any request before it or after it. So that's how REST API works. So each REST API request has its own information, and it's completely separate from the other ones. So that is something which which we need to know, because when it comes to SQL, that might not be the case, but for NoSQL and for particularly Elasticsearch, each request is self-contained. Now let's look at some other uh, ways we can actually search for it. So now to search through page hits, to search through the search, and we have the account number in order, but you just need everything from 10 through 19. So start from 10, or start from size 10, start from 10, and only search until the next 10 files. So 10 to 19, and we can run the same thing. You can copy it as curl, or view in console directly opens up this page. So Elasticsearch has this really handy thing called view in console. It opens up the exact same page and runs it for you, but we know how to do that, so we'll be doing this right now. And as you can see, it only showed you the top 10, starting from 10, all the variables. So you have account number, balance starting from 10, 11 to 19. Pretty simple to actually use it directly. And now this is good because we are using the sort function from and size, which are easy to learn. But what we need to do is actually search for something internally, search for a phrase, search for a name or a number. So that is where the query function comes into the picture. So now let's use the query function, match the address, which is mill lane or mill or lane completely. So this piece of function will match the address key to the mill lane value, but it only searches a substring, so it contains either mill or lane. So let's copy this again and see how this works. As you can see, it searches for all the addresses where it's mill lane. So 198 mill lane, 990 mill road. So it either should have mill or lane, but there might be a time where you need both mill lane to be present in the address, and that is where you use match phrase. Yeah. So now this will match the entire phrase, as you can see, and only matches the addresses that contain the phrase mill lane. So let's run this now. Yeah, as you can see, there's only one address which has mill lane together in it, and that is how it works. So now these are very simple queries. These are single queries and they're easy to use. But usually you have to construct complex queries just like SQL. And for that you can use something called as bool here. So you can use bool to combine multiple queries criteria. You can designate the criteria as must match, should match, or must not match. So it's either required or it's desirable. It can have it, or it should not be present in your results. So let's see an example here. We need to search the bank index for accounts that belong to customers who are 40 years old, but excludes anyone who lives in Idaho or the ID of that place. So it's a complex query, so we need to use bool. And the customers must be of age 40, so it must match the age as 40, but it should exclude or it should not match anyone who lives in ID. So it must not match people who live in the state of ID. So pretty simple, pretty clear. We'll actually write our own queries in the next video. I'm just going through the queries given by Elasticsearch, but in the next video we'll actually write our own queries and see how easy it is to write them from scratch. Let's copy this and run so that we know how it works. As you can see, it matched everybody from age 40, and none of them have the state ID as uh, Idaho. So it's MOOR, PA, MT, etc. etc. And yeah, so use bool to create some complex queries here. Now let's take it a bit more complex and use something called as filter. So it filter affects whether or not document is included in the results, but it does not contribute to how documents are scored. So now, for suppose you want a request that uses a range filter. So you want to range between some files. So for example, you want people who are not underage, but also who are not senior citizens. So you want people who have their starting age from 18 and they go up till 50 or 60. So that is where the range filter can come into the picture. Here they have used it to check the balances. So if you want to get the results of accounts with a balance between $20,000 and $30,000 inclusive, what you do is you have the range filter and you want to range the balance, which has the amount. And now we have something called as GTE and LTE here. So GTE is greater than or equal to, LTE is less than or equal to. So what this is doing is that match all the documents but filter them by range on the balance where the balance is greater than or equal to $20,000 and less than $30,000. So let's copy this and just make sure that it's running again. It should be running. And yeah, as you can see, all the hits here have the balance. Can I see the balance? Yeah, which is greater than $20,000 and less than 30. And that is how you actually run or have generate queries, simple queries using Elasticsearch. In the next video, we'll actually generate our own queries, see how we can deconstruct a very complex query into simple parts and then make it up again. So we'll use a top-down approach here in the next video, and we'll also talk about how we can actually get documents with a relevant score. So we'll talk about how we can prioritize some results over the other in the next video. Thank you for watching and have a great day.